Okay, so we'll move a little forward on this, and we'll do the second part, start working on the stairs. But you see this center point really isn't in the center of the model itself. It's in the center of the surface of the entire drawing, but not really what we want. So what I'm going to do is I'm just going to jump in here and make sure I can grab my layer and make sure I can unlock it so I can have a peek at it. A little bit of fidgeting. And then that layer itself, I'm actually going to move that layer down till it kind of snaps close to here. Now it's not perfect where I want it, which is I really want the corner on here. I'm just going to take off my spheres for a second. But I really want the corner of that entire drawing, which can be this corner right here, marked right to here. So I'm going to take off my grid snap. I'm just going to grab my move, move, and I don't usually like doing too much in Rhino, don't ask me why. Select objects to move, select objects, press enter when done, select objects to move, there we go, and I'm going to move it from here right to here, and I'm okay with that. And that's going to center our model right there. But in doing so, I'm actually going to override our reference square, and I'm actually going to make that reference square fit exactly here. So I'm going to just quickly kind of cheat. I could do a surface from 2 points, or from 4 points if I wanted to, and I think corner to corner. So I'm just going to grab, and I can do object snaps now because I want to snap right to that corner. And then I want to bring it out to this corner right here, but it may not line up fully. So I'm going to take my grid snaps off now and just put it right to as specifically accurate as I want on the outside of the gray, right to there. So I have a surface that if I take it from top into surface mode, I have a second surface here, which is this one, and I'm actually going to make that set 1 brep, and I'm going to internalize that one. And now I don't really need that one anymore. I can hide it temporarily. I don't really need the first one. So that's our floor reference image, but the layer was of the other one. So I'm going to lock that one, and then I'm going to go into default again, make another layer, and say floor. I'm just going to say the Parthenon ref, and that should be okay. And then I'll take that one and I'll make that change object layers to here and lock that one. So that's more of a surface that's been internalized. It's not really necessary to even see it, so I'm going to take it off, and I have the other image which is locked as well. So that's just something that is going to make it a little easier to build a reference grid exactly to that one. So that's going to do everything again. As I turn back on, it's going to center my point here more towards the center of this entire drawing, which lines up pretty darn close to the center that's indicated here. So I'm okay with that. I don't have to state all these specs at all. It's just going to be a quick reference. So nice little way to fine tune it. Any fixing you do what's called upstream is going to make your life a lot easier downstream as things get more and more convoluted and crazy and interdependent. So that's enough said there. Let's just take it and save the document. Let's actually save this one as the continuation of the Parthenon. And I'm going to call it probably tutorial. I'm going to call this one tutorial. And we'll call it 001 as we get started. So I have lots of files here. I just put everything in because there's always something worth learning on anything you're doing. So what we're going to do now is basically continue and use some of these things. I'm going to use the curves. So I am going to output my curves because I want to use those. And a little trick as I move these along so we can keep our spaghetti organized. I also want my center. I want my frame, so I'm going to grab my frame as well, and I'm going to grab that one, and pull it down here and start kind of thinking downstream as a new script I can group. What's nice, and some people get used to this, is wire display can be taken to hidden, and wire display can be taken to hidden. And I have to do that for the first one. And there you go. When you're not clicking it, you won't see where that wire is connected. It's just kind of remote connected. But you've got your outer curves, and you have your, and we may end up using probably, I can imagine, the point center as well. So it's not going to hurt us to just have that as a quick reference. So we don't have to relay wire and make all the mess that Grasshopper's so good at making, or I'm good at making. Wire display hidden. So we can indicate what these are if it's needed, but it's not really that important. What I do want to show is we're moving on to the next phase, and some of the things I want to do, I kind of want to write down. I'm going to work on the steps. So just to keep the same size and font of what I'm dealing with, I can cut and paste another text, erase it, and say I want to work on steps. The steps, and just a little note about them, have a curved profile, so we're going to work on that, which would be a little different than what you might expect, rising towards the center, which is our center point. The treads are set slight upward tilt, so that's another thing we're going to have to take into consideration. And the devices of perspective correction produce a complex geometry for construction. So really, take your time when you look at models. Don't do things the way everybody would do them. Allow them yourself a little creativity into what's happening. I hope I'm not going too fast. I hope I'm not going too slow. But what I'm going to want to do is I'm going to want to take those curves that are coming out, and you can see them here because they're the boundary representation. They're what's been split out of that surface, that breadth above. I'm basically going to want to do some curve manipulation, utilities, and I think it's right here, but join curves. And that way I can take what is reading as 4 curves. Please get into the habit of starting to use the panel tool to know what's contained within what's happening. And definitely we'll have to get into knowing how our data trees are structured in order to use some of the set tools. We have one branch with 4 items on it. So we'll just leave these here, and we may pull from them a kind of a visualization tool for data, and we'll do that. But as we pull out these curves, you can see that we move from the 4 curves to the 1 polyline curve closed. So nice little thing to start, and that's enough to begin with. I'm going to enlarge my scripts and see what I end up doing with it. Those curves, if I move along farther, I am going to basically scale non-uniform. And why I'm doing that is because I don't want to scale evenly in the X, Y, Z, but I want to put it through a kind of nice system of how to do that. So I'll try and do this as clear as possible. In your transforms, you're going to find the scale, but you'll also find the scale non-uniform. We're going to move that geometry over, and you'll see we're dealing with just a single item. But we can do things with it in the XYZ and start to consider what is happening. And in doing so, I'm just going to elongate my perspective and elongate my, maybe I'll leave it so we can kind of take a look at the front and sides as well as we go. And we'll just see how that works. And you can zoom extend just the panel you're on, or you can zoom extends all. But let's see what ends up happening. Now, one thing you're seeing is you're not seeing your surface, you're seeing that surface that's above. So everything here we can kind of disable, and then we're not bothering with it. And then only when we kind of select on these areas, we're seeing the geometries we're still working with. You technically don't have to see all those broken up. And the plane's very small. If you have small planes and you're not happy zooming in and seeing what they are, the display has a wonderful tool for display plane size. And I will make this plane size 6. I think I did that. 6, enter, and there you go. You're seeing a much bigger plane size, making sense for what you want to look at. It's actually probably too big because I'm going to actually look at individual plane sizes. So I think I actually am going to keep my plane size somewhat smaller, and we'll put it to 1 to begin. Because I will want to move that plane size around the points to make sure it's at the base of these columns and I can see the orientation of each one in the X and the Y. Okay, so what are we going to do to this? And we're going to try and keep things to single units to begin with to see how they stand. And one thing to do that is go to curve and just grab yourself a circle and see how big it is as reference. And it will be turning up at the center right here. And it's a little larger than the biggest column. So I'm okay with that visualization scale, but it just gives me an idea of what I'm actually looking at. The sphere does the same thing. The mesh sphere does the same thing, set at 1 radii. What we're going to do is we're actually going to control and use this quite a bit as we go through. We are going to set not just a number, which is your initial stage of what you want to do. You'll probably start with a range that you can play with, but it's gonna make for complex geometry if you do too much with it. So I'm going to, let me think about this, maybe just a number to begin with, a small slider to begin with. Let's see what happens as we start to scale out this box right here in the X, Y, and Z. So let's throw on a value of 2.00 and see what happens in the X. And we have to choose our new object. You can see that that scale is very small. So this is a little too small a scale for what we ended up wanting to play with. The 1 unit's okay. It's do-si-doing around a bit. I guess it's all right. I guess we can kind of step out. What I may want to do is either make my entire model larger, which you can set the scale to the Parthenon if you like, but I like working small just because I like a lot of trigonometry to get my models working. You can always just take the whole thing and export, change the scale, whatever you end up taking it to fabrication. So we're just going to edit that and pull that up into probably a 4 decimal range to give us a lot of little finesse as we move. And the closer you zoom in, it's kind of nice. You can see that you get this kind of finesse of how you want to move that square in and out. So I think I'm okay with that, just moving it out a little over 1. And I'll probably throw the same value in to the Y. So we can see that that's moving out, even though the Y I may want to move up a little farther and out of the way. That's the first step. And Z factor, I want to move it actually in a negative direction. So I'm going to move it in a negative. And I'm going to take a similar value. Instead of inputting a number slider at that, I'm going to move it down to a very small number. I'm going to bring it to 1.000. I'm going to bring it to a very small number subtly down and make sure as I move it, I'm scaling that one down. Now, the scale won't do much initially if you take a look at it because it's a line, so it can't really scale something that doesn't have volume. So just something to think about as we look at it. There's no real way of taking that line, and even though we're extending it out, we want to move it in a, you can see in an X direction, and we want to move it in a Y direction, which is what it's doing. It's scaling out from the point, but it's not scaling out from center. So I'm going to make sure the center of the plane is here, and that way I get it moving out in all directions around, but not actually, if you take a look, moving down in the Z no matter what factor we put on it. It's scaling a line, so it's not doing anything. We are going to use it a little later on, and I'll show you what we do. So we'll just keep moving ahead. We're going to bypass taking that result of Z going down with Control Shift off of the stretching out in the X and Y. And we're going to save it for a little later, that then we're going to take that geometry and we're going to move the whole thing scaled out over in transformation by a move. Then we'll take that geometry and move that down in the z. And that's going to allow us, now it's in a negative and we've overridden the z factor, which is the default, so we have to put it back in. So we have to put it in there, and now we have a line that's actually dipping down. So it's dropping as it's moving out. So just a nice little subtlety. But as we look at that, we don't just want that line dropping down from itself. We actually want to throw in a range, and this is where the ranges start to have a factor by a matter of steps. Because I want my step to actually be 2 and not just be this range, I'm kind of playing around with this, I am going to throw these numbers through a range and divide that domain by 10 steps, but instead of defaulting the 10 steps by each one of these, I'm actually going to set it, hard-code it to 1, which will actually, because the range tool adds 1, give me 2 numbers. And I'm going to take that list now to the x and y and move it down, and you'll notice what I have now. I not only have the geometry that's been moved out, I have the geometry that's moved down. So think about that. I have my 4 lines that are joined into a polyline, and I want to be able to, let me do a zoom extends all here. I want to actually move this line to come down to this one in a loft formation. And this is where it gets a little fancy. The one thing you may want to do is call your indexes of the data that's coming out, because now you want to start controlling data. I'm going to stay really simple with this. I'm going to call an index out of this run to get rid of the last item in the list, which is actually the second line. So I'm going to call out hard-coded -1, which is the last item in an index. And this will get you thinking coding if you do this. And I'm going to call out what is the first item in this index, which you start counting at 0. So now I have a line that's here up on the first step, this geometry that was initially here, because I don't want both of those geometries. And then I want the last line of this one. And you can use dispatch and all these wonderful tools and sets to think about all the patterns, but I like things that are simple. List item calls, list item indexes. And what I'm going to do is then, because I brought them together to scale them, I'm going to use something which is a wonderful tool called explode. And you can explode trees, but you can explode lists, and you can explode curves, and you can do anything you want. Explode. I'm going to do that to both, because the reason is corners are kind of tricky when it comes to lofting. But if I take those 4 segments, keeping in mind that I have these 2 tools to tell me exactly what's going on in my script at any time, the segments being 4 invalid curves, that's always nice. What have I done? My segments need to be grafted. And I have invalid curves. Now that's a little frustrating. How did I end up with an invalid curve? The segments, the tree, the segments are lofted. Not sure why I'm ending up with an invalid curve. We'll figure it out in a minute. I also want to know how these segments are making out. These are line-like curves, grafted. So those are line-like curves. These should be line-like curves, but for some reason, going back to this geometry, I've got my curves initially within my form. The curves have been put through a range in the X, Y, Z out to here. Let me think about this. My curves are my list, which is coming here from my plane, so long as I've done it correctly. My plane is my, maybe I should draw my plane as my point, which I don't think should matter at all. Line-like curves, invalid curves. I'm very interested in that. Polyline. Let me try and figure out what I've done differently here. I don't think I did anything. My domains are set to my domain starts at 1, and I will have to go back into here. Now I see what I've done. My domains have to start at 1, but my domains actually have to go to a domain range in distance. I have not made my domains. That's my problem. I have my ranges and I've not put in my domains. So I'm sorry I missed this. I want to add my domains. My ranges, this number for my range number is set to 1. But also, I'm going to cut and paste this. I'm going to use my 1 to start my domains for my ranges. And I'm going to make them push through these distances because I have to use those numbers, put them into the domain here, and the only thing different down here is even though I was using this to drive the Z factor through the range, which is still what I want to do, I want to grab another range, come here, I want to grab another domain, push it through here, range 1, and I want to make sure that this one starts at 1 and this one goes to 0. Here we go. So this is just playing around with my domains and ranges that I'm going to start at 0. The other one I'm starting at 1. And I've got my factors being pushed in. I want another number slider that's very small, 1.00, and I want to pull that range way down. That will go through a negative, which is what I was doing here. And I will take that to this domain. And just ensuring I'm doing things correctly. This 0 domain comes here. I've set up my domains and ranges correctly. So now, when I pump through my numbers, I should be getting my line-like curves, my line-like curves. And that is kind of a visualization of playing off of a simple staggering, which you can take farther to do more steps, but I'm going to show you an iterative process that's a little different from that. So as we plug through here, and then you can visualize what happens in Hoopsnake and Anemone. So what I'm going to do here is grab these two trees, which are producing two nice sets of lines, and I've grafted them, that a loft would work. It's going to start slowing down my scripts. And whenever I bring in more than one item like this, because order can start to matter, what we have is a step, if you take a look here, that doesn't just come out, but it has the ability to be a slight tilt on the step itself. And of course I can bring it out farther in the Y, and I can bring it out farther in the X, no matter what size I want. So I've got a very subtle step that I can push down and lift up, and that's a nice way to have the top of this stair and have pretty good control over what's happening. The thing I was going to mention, when you start doing this, there's a tool that Grasshopper 1 uses quite a bit. Control-Shift will take all data out and move it, but because the merge tool likes to see what you're inputting, it will add more inputs as you go. That's a nice way to know what you've done, and if you want to get rid of the third one, knowing that you're not going to add more, that'll be fine as well. So just the top of the step, subtly playing through a range to control with a little bit of culling index, so you start to think of your data and where to drive it and when to move it out. Now that's a huge step for the Parthenon. None of these numbers have to be this big. We just want to pull them back so this isn't so steep. Really subtle step, and when you start getting into the details of how you actually want this to be and you get your numbers close, you can see that this is such a small number that I can go in and edit and realize I don't need anything that high. 1 would be more than enough to be the maximum value out. And over here, edit, 1 would be more than enough for numbers out as well. So I don't need to move a step out any farther than that because I'm scaling and I'm not thinking so correctly. I want to move from 1 to 2, and same thing here. I want to edit and move so it's at least coming up the full shape of what was there and then stretching out almost double to what's there. So as we scale this, you'll see that we start to move out in the X and Y direction, and we have the same numbers we had before. So I'm going to edit this and maybe scale up my whole thing. I'm going to come down to 1 and just scale up to 1.1, and I'm going to come here and edit and scale up to edit 1.1. And so that will give me the ability to kind of bring it out, not outrageously and outrageously in the other direction. And if you want to see in both cases right here, you can see that you can play off of the edge moving in the Y direction here. So you can pull that nicely out so it kind of balances. And you could always use the same sliders on each one, depending on what you want. This one goes up to 1.11 as well, but it's scaled according to the size of the side. So nice little fresh stop, using little domains and ranges to start exploding, getting into the habit of culling out information, shattering, and lofting that top step. I don't want to leave it at that because that's a little boring. But another thing that you can do is take those geometry segments of this bottom one, which are all the rims around here, and think of moving not just the top of that step, but thinking what you want to do in the negative to shift that down. And this is where we don't want to have a straight drop, because if we remember what we wrote, those stairs are concave as they come in. So convex, if you're looking from the outside. At the temple, they're convex. So what we're going to want to do as well is we're going to want to once again grab this data as a segment and use our explode tool. And this might be practices that you kind of did in Rhino. So we're going to bring in the curve and we're going to explode it into segments. And that's exactly what we already did. We want to take the segments and we want to use our curve tool to join. I'm kind of new to watching my own tutorials, so you kind of have to bear with me as I'm kind of making my way through this. And I want to go back to scale non-uniform those geometries. But this time, I want those to be scaled to the plane that I had in the middle as well. So I can follow that back to where that plane was, which was my initial one that I brought in. And this is where things start to get a little wiry. And you sometimes want to, grasshopper 1 behaves pretty nice here, scale to that plane in the center, which is that center point. You're also going to want to follow back the scales of X and Y to some results. However, you may want to multiply those results. So what I'm going to do is I'm going to grab a couple of those things that I'm working on, and I'm going to allow myself back to draw data like the number 1, but using math. And one of the best things to scale is multiplication. You won't need division if you think in multiplication. You won't need subtraction if you think in addition. Let's just keep that 1 unit and take something that we can scale to in the X and Y as a factor. And we'll probably want a factor that's as small as the other ones we were dealing with before in the Z. And I did mean to attach the 1 to the top. And then I'm going to plug in these ones to the bottom. I'm going to get some small numbers here. And with those, because they're going to play into this as well, I'm going to have those be the factors that are going to drive a lot of data, actually quite a bit of data. But for right now, I want them to go into the X scale and the Y scale, because I want them to move out yet again. And what you'll see is these curves have managed to move out well, not out because I've kept them so small, under 1. I've got to set that number slider to at least 1, and we'll take it up to 2, and we'll move that so it scales out from that center. But we want to actually scale these geometries which are on the outside, scaled from the plane in the center. Let me just think about this and check my script. The geometry. The problem with these curves are they're coming in as a tree. I need to flatten these so I get a script moves out from where we were, from that center plane. And that should be good in all ways, considering, but the geometry is not so much this one. Let me think of this. Curves here. Let me think where I am. Curves flattened through here. I want to grab those curves that are there, that I've moved in many directions, and I've got a pretty good multiplier on them, which is maybe too much of a multiplier. Let me think how my multiplier is set. I'm going to shuffle around. Very small. I'm actually going to set this slider to very tiny, probably 1/100th of where I need to be. And I think I might take the edit tool up to 1 here and leave that at kind of a 0.007 on scale, multiplying out. And that's come out a little ways from where it had to be. And we'll just kind of plug through without sitting on this, trying to figure out everything as we go. Take this geometry and drop it down. And we want to move that in a negative direction. Negative direction to the z factor. And all the way back to the same top multiplier. So we've kind of created a vector that moves down from that step, directly underneath where that step ended. Don't let the drawing throw you with this outer step of where the Parthenon is. If we wanted to do that, we could come back in and take this initial one and, let me just think of this, not move it out in that direction, but move it out in this direction and advance these numbers. So sometimes you get confused looking at, I'm going to move it out by 5 and see what happens here. As we move that out, we could take that first step over to here as the base, but it technically isn't where the first step is. The step doesn't really begin there. That's just an outer border. The steps are actually in closer to the Parthenon right there. So I'm starting on the farthest step. So I think I will just keep it where I was and not let that kind of throw me. So yeah, the step's okay there. It's larger than these steps that start right at the columns dropping down, but that's just the nature of it. So I'm going to go in here and grab my drop. And after I drop that down, it takes a little time to think these things through, and then making them iterative is kind of fun. That's the geometry that's dropped. And what I want to do is grab these curves and these curves, which are a move. I want to explode them so I can do exactly what I did before. And repetition is usually how you end up getting your head around things. And I'm going to explode these ones as well that have been joined. And now I have two sets of lines, the top and the bottom. And this is where I want to make a convex stair coming out. So what I'm going to do is actually go to curves and produce a line between the vertices that goes straight, what seems to be almost straight down. But I want from that line, the four lines, to use the curve tool to find the point on curve or the midpoint. Maybe I'll do point on curve, which is kind of interesting why I would do that. Point on curve is going to allow me, it's kind of an interesting function, to find a point as it moves through here. And I think I will use that one because that as a midpoint can then be moved away or scaled, which is interesting. If you think of the midpoint or this point, I can actually just use the transform without vectors to scale that geometry away from center, which is a default of just 0, 0, 0, which is not a good spot since you should be using this point whenever you do things like that, because you don't want to default to the map even though you shifted center. And the factor is going to be fairly small. I'm going to keep it very tiny, about 1,000th scale. So I'm going to have it at 1, 2, 1.001, 0.010. And now I can have a factor that's very tiny, like 0.003 factor. And even though I've scaled the four midpoints, you can see that I can control moving that in and out away from the center, which is kind of like using a vector and moving it away. And it's actually moving along that line on diagonals. If you take a look at all these points on each corner, they're all moving out away from the center to where that curve is gone, which is kind of awkward. It's not parallel with the vector coming out. The stairs are doing different things, but it's staying along there. And what it allows me to do is use an amazing tool I like of primitives in arches. And I like arch 3 points because my midpoints can be those points and my starting points can be the geometries of those vertices. Now you could also grab this and get in the habit of using endpoints. Curve, take all your starting points and all your endpoints. Of course, you could have went farther back, but now you have an arch that's concave and convex that you can control a pretty cool arch to how you want the edges of that building to look. And that's kind of a strange little thing to think about. But let's continue. And then we want that arch itself to be used on, because you have four arches, we want to actually build a kind of flexible, how should we put it, loft that flows along there. So you probably would find a surface, freeform, sweep one rail. But because we have two rails, freeform, sweep two rails would be nice. So if I grab this and I start using this tool, which a lot of novices use, I like it. I like, because there's four rails, I could grab the arches and I could just take them, and I'll go back here, make sure the arches go into the list. I could take that data and do some very interesting things. So I could grab the first and second rail as the rail, and the sections itself could be the arc. Sorry, this data comes down here for the next one. What I need is another list item that's actually not coming from that list, but actually coming from my segments. So if I grab all my segments and pull it into the list, and I have the same index, I should be able to grab the first index in that list and produce that nice flowing rail that comes down the sides that behaves with that finish. And this is kind of the similar thing you have to keep doing, grabbing the next one. And it's a little clumsy, but it is very visual when you end up doing it. I want to use the same rail starting and give it a count on each one, that this one I want to cut and paste. And then I want, for the next system, to use the second rail as the second section, and I want to use the first and the second one. And you start to control your data and start thinking about what's actually happening as you're creeping around and trying to cap these ends to what's happening. We have 1, we have 2, and we'll just kind of pitter around here and see how we do on, it's kind of hard to make out in this angle. It's probably best to just have something like full perspective as we go. So I've got that one. I'm looking to get the next one. Now I'm looking to get this one. And I'm just going to do a zoom extends all. And I'm looking to get the last one. So we can copy this whole thing again. Gives us all of the data. And the only thing we have to do different is grab that first rail item and the last one. And we have to ensure, hang on, I did something wonderful. I got ahead of myself. Let's make sure that we're taking the first and the last item. And what have I done wrong? I need this rail, because you have to change up which count, what you're pulling. This was 1, this was 2, and it's a little out of order, this one. And you just kind of have to play around with it until you figure it out. First rail and last rail. And the one item we haven't used is 2. And there you go. You've managed to make those steps that are ready to be iterative, that I know it's taken a lot of time, and you've taken a look at this differently, but look at what you have. You have something that's a little more playful and complex than what you initially would have, but steps that come out that can then be taken through an iterative process, and continue making those steps, thinking of these as units. Now, if you think about it, they all came off of an initial boundary curve, which is actually made again right here. So if you grab this data, this last bit of data, and you take this entire script and copy it from the scale factor, the initial scale factor of this one, okay? And you take all of this information, we can get rid of these. We have the loft, right? We can take this whole system, which is very nice, the move. We don't really need the z factor because we're going to stay with the z factor. We can maintain all this similar data, but we literally can grab all of this system from here and cut and paste it here, which is clumsy coding. But because we started with a geometry that was a set of curves coming out of here, that geometry was this geometry. All we have to do is take the previous geometry and haul that down here into this geometry, and you end up producing a second step. And what a visual way of thinking iteratively. It's clumsy, but Grasshopper doesn't have that iteration. You don't have to get into huge data trees, but you can continue to do this, going to the geometry, take the next end of the last data, and Hoopsnake works the same way, and you can continue this as long as you want, building step after step after step, which is always kind of fun to think this way. Group and group. And you can start categorizing what you have. So things kind of move faster after you get the base of the script. So we produce some steps that not only as we look at them from the side, and we look at them from the top, and we look at them in perspective, you can go back to that initial data and really start driving those curves. And I think we had some data farther up here that was doing something. This, which is each one behaves different. You probably want that to be the same, which is why I was thinking of just using a curve midpoint. So that would be easier to plug this in here and plug this in here, because that would be repeated at the same thing. But even if you keep this data and you don't want to change it on each one. So because I did it this one, I'll just leave it. But the data you have here is controlling this script, but it also can be removed from group. It can also be the data that you have to keep your parameters out of those single functions. So pull it in here, get rid of that one, pull it down here, and get rid of this one. And that way you're staying, it's like working the model of the first one, which has an effect on all the other ones. So I should have pulled that out initially, but you have your parameters here, which are worth labeling, and here, which are worth labeling, your X and Y. And if I think about that for a second, as I go into here, I could consider giving them names that would help me. But because I pretty much can figure them out as I go, I might just group them and then call these step parameters. And that allows us to have a little more finesse as we move things. Make a beveled staircase, a staircase that doesn't drop very much or drops a lot and is steep, and it allows us to control that concave and convex nature of what's happening. It's subtle, it's nothing too fancy, but if you pull it back, that's more accurate to what's happening in the model at the Parthenon, and it would make visiting there more interesting. That's a 47-minute demo to just think of the stairs and start using your scripts. I'm going to take all of this to preview off. The columns are a little more interesting as we go. I'm not sure why I have all of these on. Oh, because this is the loft information on the top. This is the loft on the second. And this is the loft on the third. So I definitely want to select those and ensure that they are preview on. And now I can see the steps I've made for the Parthenon, and I can start working top view on how to locate and grid and mask and find the data to drive all of these different columns. And just to get you interested, you'll realize that the corner columns come towards the center, whereas the side columns fall towards the center, just towards the X and Y. They don't actually go towards the center. They actually just fall in the XY direction. They're scaled bigger, and there's interesting things about those columns as they taper going up. You're going to figure that out. We're going to do some really interesting things with polar arrays and lofting, making drums. Then the inner columns of the nous and the statos, I think it's called. I have to check it. Where the statue is over here in the nous. They're different size and scale, and they move in different ways. And we can kind of custom kind of digital assets and make parametric columns in this model. We don't have to go and find models online and import them and position them, but you could do that. But what we want to do is learn how to tilt and twist and make these move on these bases. So I know that's close to an hour. It's slow. I don't make tutorials this way. I'm trying to get my head around it. People are asking me to build things, so I'm starting with the very basic stuff to start. I hope you enjoyed it, and we will just keep moving forward. Thanks for watching.